Hi, this is Chris again. I'm here to talk about the law of sines. This is from Unit 66 in the Mathematics for Machine Technology book by Smith and Peterson. I'm an instructor at Shoreline Community College. The law of sines states that in any triangle, the sides are proportional to the sines of the opposite angles. So given the triangle ABC, the length of A over the sine of angle A is equal to the length of B over the sine of angle B is equal to the length of C over the sine of angle C. We use this in triangles where we don't have a right angle to solve for the length of a side. Let's see how this works. In this example, we're given two angles and a side, and we're asked to determine side x. So, using the law of sines, x over the sine of 36 degrees, the angle opposite it, equals 3.5 over the sine of 58 degrees, the angle opposite it. We cross multiply, and converting numbers to the sine values, multiplying, and then dividing, we find that x is equal to 2.452862864, or rounded 2.426, or 2 and 426 thousandths. And that's our answer, the length of x. Let's look at another example. In example 2, we're given the length of two sides and one of the angles, and we're asked to calculate y. First, we have to calculate angle B in order to calculate angle 1 to calculate y. So angle B, to calculate angle B, we use the law of sines, 6.0 over the sine of 63 degrees 50 minutes, and that equals 4.5 over the sine of angle B. We cross multiply and then divide both sides by 6. So the sine of B will be equal to 4.5 times the sine of 63 degrees 50 minutes, or 4.03881,784, divided by 6.000. And we find that that's 0.673136307. When we look up the sine function, that's 42 degrees, 0.30959041. Now, to calculate angle 1, we subtract the other angle, and this angle we just calculated, B, from 180 degrees. We'll convert the 6350 to decimal degrees. Now we add them together, subtract from 180, and we get 74.85707,626 degrees. Finally, we calculate side y, again using the law of sines. So side y over the sine of angle 1 equals 6 over the sine of 63 degrees 50 minutes. We cross multiply and divide, and that gives us this, substituting in the values. So it's a sine of 74 degrees 85.85707,626, which is 0.96527720025, which is 5.79166,3201526. The sine of 6350 is 0.89751507550837. Divide that, and we get 6.452998238771105. Rounding that to 3 decimal places, we get 6 and 453 thousandths, which is the length of side y. In some cases, we don't have to use the law of sines. There's an alternative way in some of the problems. in the original, the first problem, if you take a look at that, we could actually use drop a vertical, and then that will allow us to solve the problem without using the law of sines, because we can just use the sine function a couple of times to solve it now. So if we drop a vertical perpendicular to the base, and then if we first calculate side O, we can then calculate side x. Calculate O, we use the sine function, since we have the hypotenuse and we're looking for the opposite. Opposite over the hypotenuse equals the sine. Rearrange the equation to solve for the opposite, and we get the opposite is 2.057248383. Now, we can use that we know O, we can solve for x in the other triangle. Again, using the sine function, since we're missing now the hypotenuse. We've got O, x is the hypotenuse. We rearrange the equation here. So we divide 2.057248383 by the sine of 58 degrees, or 0.848048096, and we get 2.425862864. When we round this to 3 decimal places, we get 2 and 426 thousandths. The same thing we got when we solved for it using the law of sines in the initial frames of this program. I hope you enjoyed this lesson. Bye.